Hello, everybody. Welcome to our webinar series. My name's Becky Hemingway, and I will be your host today and start the presentation. I've also got two colleagues, Gabriel and Milana, joining me, who will present on various topics. Now, this is the webinar series entitled Machine Learning for Operational Forecasters, and this is the first webinar of the series. So it's called Discover Machine Learning Models for Operational Forecasters. I'm very sorry, I think someone's taken control of my presentation, so I'm going to have to take it back for this. Just coming up again. I just wanted to start with a welcome and the aim of the whole webinar series and why we are doing this at ECMWF. Now at ECMWF, we have been doing machine learning for a number of years now. However, the focus has mainly been on the more technical aspects, how the models work, how to create these models. And what we wanted to do is give you a bit more of an operational perspective on what you may need to know as operational forecasters in order to use ECMWF's machine learning models outputs effectively. So over the next 3 webinars in the series, so there's one today, one next Tuesday, and one the following Tuesday, we will take you through a number of different aspects that we think would be helpful to you as operational forecasters or users of our forecast products at ECMWF. The main reason is to encourage you to use these, to give you information that will be helpful to you, and also to encourage you to provide us with feedback on how the models work, how you use them, where they perform well and where they perform less well, as this consistently helps our developments and our understanding. Now, the way this webinar will work, and the other ones as well, is please put any comments in the chat and any questions. There are a number of ECMWF colleagues online to answer your questions in the chat, and at the end we'll also answer some questions as well and raise the ones that are of most importance, for example. Your comments on your use of machine learning models in your currently in your organizations are also very welcome, as we would like to better understand how you currently use machine learning models, and that will help us as well. So the first webinar, so welcome to it. I will do an introduction on what the machine learning models are and basic information on them and how to access them. Gabriel will then do the basics, give you the basics of how a machine learning model works, the differences between AIFS Single and AIFS ENS, and a bit on the future plans for these models. And then we'll finish with demonstrations of how to access the machine learning model forecasts by Milana, and this will focus on ecCharts and OpenCharts. So just a quick summary of the machine learning models at ECMWF. So we have the AIFS, which is the Artificial Intelligence Forecasting System. And of those, we have AIFS Single, which is the deterministic model. This was first released on the 25th of January this year. And we also have the AIFS ENS, which is the ensemble model, and it first released on the 1st of July 2025. Now, the name you'll see is very similar to our current numerical weather prediction system, the IFS. So it's the artificial intelligence version, and Gabriel will explain how it works later on. If you want more information or to see our releases, kind of what we said when we first released these models, please go to our website, and in the news section, you will see our announcements of the models. So here is our current at ECMWF operational forecasting system. The first 3, so the ENS control, the ensemble forecast, and long range, are our IFS models, so numerical weather prediction. And now, because of the release of the operational AIFS models, we also have AIFS Single version 1.1 and AIFS ENS version 1 in our operational forecasting system suite. And I'm going to go into a little bit more detail over the next slides on their resolution, the levels, and how the time steps and how long they run for. So here's a summary of AIFS Single and AIFS ENS and the key configuration values, which we feel you do need to know. So first of all, they run 4 times a day at 0, 0, 0, 6, 12 and 18 UTC. They run out to 15 days with 6 hourly time steps, and this is for both of them. Step 0 is from the AIFS analysis and therefore has 0 values for accumulated fields. This is the same in all of our models. The other key points here are the resolution of the AIFS models are currently around 32 kilometers. And they also have vertical resolution of 13 different levels, and the ENS has 50 members plus 1 control. Now, a bit more about the model level vertical resolution. So AIFS has 13 levels, as noted here. This is in comparison to the AIFS, so the numerical weather prediction model, which currently has 137 levels. So you can see slightly less levels in the AIFS currently. In terms of forecast parameters, the AIFS has more limited parameters compared to the AIFS. Here you can see many of the parameters. So we have the different fields at the different pressure levels. We then have various surface levels as well, through a pressure, soil moisture, for example, horizontal winds, total precipitation and convection. So this is for AIFS Single. These are the parameters that are available. Now, when we go to AIFS ENS, so the ensemble, we have the control and perturbed forecast members, so the 50 perturbed forecast members. And here you can see, again, for the different pressure levels, as well as the surface parameters and soil levels, all the different forecast parameters which are currently available. There's also more information on these on our implementation pages, so please have a look at those for more detail. For AIFS ENS version 1 as well, these are the post-process parameters. So you can see we have things like 2 meter temperature, wind speed. We have total precipitation at different rates as well. So these are all post-processed, and you can look at things like the mean, the standard deviation, or probabilities depending on the product. So again, more details on those implementation pages. Now, updates to the models. So all the models, AIFS and AIFS, are operational. So they adhere to the operational upgrade procedures. So for each big upgrade, we do implementation pages and series of webinars telling you a bit more about what's happening, both scientific changes and more technical changes as well. In all cases, test data is made available prior to making the models operational. And this allows you to test in the systems how that data works, and also look for differences in the forecasts. As we upgrade the models, you'll see changes in biases, for example, and ways things for the forecast over your location may look slightly different, be slightly, hopefully more improved, but you need to understand those biases as well. We also have communications. So we do various communications about those model updates at the same time. So under the current plans, AIFS Single and AIFS ENS will both become version 2 at the same time as the AIFS 50R1, which is currently planned for early 2026. And then smaller updates, for example, we're at version 1.1 for AIFS at the moment. They can happen at other times. All of this is documented on the implementation pages. In terms of how to access the model data, so there's various ways. The first is through OpenCharts. This is free to access for all, no login required. It's a really great web page that you can look at many ECMWF forecast products on. We also have ecCharts. This is where a login is required. If you're from a member or cooperating state, you should have access to these quite readily. However, if you're from a WMO country, you can access, you have one account for ecCharts via your WMO_XX, So your country, your 2-letter country code user ID. And for both OpenCharts and ecCharts, Milana will demonstrate this later, how to find the model forecasts. There's also a web map service where you can pull data through to your toolboxes, to your forecaster workstations. Your IT department should know more about how to do this, so please contact them. And it's the same license as you may have for ecCharts. And on the open data side, again, free to access for all with no login required. And this is the raw data, not the products themselves. So again, your IT department should or hopefully be able to help you with this. And then just another slide on how to access ecCharts in a bit more detail. As I've already said, member and cooperating states can access ecCharts with your personal organizational email addresses or joint accounts. Your computing representative from your country can help you with this. All existing WMO user IDs have been assigned ecCharts policies. So you have one account. The ID can be shared, however, you can't use the account simultaneously. So it's one at a time, but you can share that login, no problem. If you don't know your login and you are from a WMO country, please get in touch with us via our support portal, where you can ask for the details of your logins. And if you do need to change them, there is a form on our website that you can use as well. So I know there's many of you online today from many different countries. So we wanted to tell you all about the various ways to access ecChart. Now that's the basic information I hope was helpful. So now I'm going to hand over to Gabriel, who's going to present to you on the models themselves. Over to you, Gabriel.
Thank you, Becky. So yeah, I'm Gabriel Moldovan and a machine learning scientist here at ECMWF, and I'll just give a very brief introduction to how actually the AIFS Single and the AIFS Ensemble work, what's inside the black box. So we have all seen the huge rise in AI in these past couple of years. It just seems that given enough compute and data, any relationship can be learned. And this is also true for weather forecasting. But a very important point here is what data can we use, right? So this is where data simulation comes into play. In conventional numerical weather prediction systems, we have data simulation that is used to obtain analysis, which is basically an estimate or the best estimate that we can have of the actual or the current state of the atmosphere. Analyses are just fusion of short-range forecasts with the latest observations coming from the observing system. But the idea here is that if we have historical data, we can use this data simulation technique to reconstruct the past state of the atmosphere. And this is just what ERA 5 is. We have reanalysis, so we have in ERA 5, one of the most accurate reconstruction of past state of the analysis over the past decades. So this just seems the perfect data to start exploring AI models. And what is the idea behind data-driven weather forecasting? So we have ERA 5, and what we want to train a model is we want to task it with jumping from analysis to analysis. In ERA 5, we have early data, but as a design choice, it is proven to be better to use 6-hour time steps. So we'll train a model to do 6-hour forecasts. This is true for the AIFS deterministic and also for the AIFS ensemble. And then the forecast is just performed autoregressively in order to step further into the future. Becky has already given a very nice overview of the variables, so I won't spend a lot of time on this. Just to say that we cannot use the entire ERA 5. It doesn't make sense to use the entire ERA 5, so we use a subset of variables with two ideas in mind here. So what helps predict the state of the atmosphere? So we have upper atmosphere variables and 13 pressure levels, such as geopotential with components, specific humidity, temperature. And then a second idea is what the users actually want. So we have surface variables that are very important, such as 2-meter temperature, wind speed, and precipitation. And then we have some external forcings that actually are required in order for the model to be aware of the position, of the season, of the time of the year, time of the day, etc. Now, in terms of the artificial intelligence forecasting system, the actual machine learning model behind these systems, what is actually inside? So inside we have a graph neural network. In graph neural networks, we have that the data is represented in nodes and the connection between these nodes. And we can distinguish in the AIFS two different data spaces. So we have a physical space where basically we have a reduced Gaussian grid, and at each node around the globe we have this subset of ERA5 that we have chosen to represent the state of the variable. So this is our first data space, and then we have a second data space which is a hidden mesh or a hidden grid, which is also a reduced Gaussian grid, and we usually call this space the latent space. So this is where the machine learning computations or machine learning magic, you might want to call it, happens. So the whole idea is that we, as an input, we give the current state of the atmosphere and also the past and the state of the atmosphere in the last 6 hours, and this is encoded into this in the physical space, so in the data space. This data is then encoded into the hidden space, and this is performed with an encoder. And then in this hidden space, where we have a reduced resolution, so but as I said before, it's also a reduced Gaussian grid. We perform some message passing or some attention. So we're basically forecasting the state of the atmosphere first in this latent space. After these computations in the latent space are performed with the processor, we then decode this information back into the data space, into the physical space, and then we have our output, so the prediction of the state of the atmosphere at T+6. We then have a loss and a target, which is so our analysis coming from ERA5, and then we can perform the backwards propagation, and this is performed multiple times over the entire data set in order to optimize this model towards minimizing the loss function that we choose. Usually in the training scheme, we have a first step where we have a pre-training phase during which the model is given the task to forecast only up to 6 hours, and then a second step where the model is auto-regressively trained to optimize forecast between 6 hours and 72 hours ahead, so up to 3 days. This is where the rollout is actually happening. Now, let's focus on the main differences between the AIFS Probabilistic, so the AIFS Ensemble, versus the AIFS Single, which is the deterministic version. So in the deterministic version, we have our initial conditions in the data space. We have the encoding into the latent space. We have the computations that are performed in the processor. Then we have the decoder. We obtain our forecast states. We use a mean squared error loss, and then to compare this forecast against the target state, which is ERA5, and then we repeat this procedure over multiple times in order to minimize the loss function, right? But in the probabilistic version, so in the AIFS CRPS, we have a very similar backbone. So we still have initial conditions. We have an encoder, a processor, a decoder. But we have here 3 main differences. So first of all, we'll want to use a probabilistic loss. We'll still have ERA5 as a target state, as truth, but the loss cannot be a mean squared error anymore. We need to use a probabilistic one. Second of all, we'll actually be adding noise into the processor. So this more or less represents or model uncertainty in a sort of way. And then in order to use a probabilistic loss, we probably need an ensemble. So we can no longer rely on a single model realization, but we need to train a whole ensemble. So this is how the AIFS CRPS actually looks like, the training of the AIFS CRPS. In training, we actually run a small ensemble composed of 4 members. So the initial condition can actually be the same for every member, but what is happening here is that after the encoding phase, we're actually adding noise into the processor, and we're also training how to modulate this noise in order for the model to to be able to accurately represent the uncertainty in the forecast. And then we decode back into the data space. So we have our forecast, and then we take these 4 realizations in order to compute a CRPS loss. And this loss is actually fair. It's a mix of a fair CRPS and a non-fair CRPS loss. And then we compare this, this CRPS loss is actually computed taking the era 5 state as truth. Let's now focus a little bit on the differences in the loss function. So CRPS versus mean squared error. This is actually very important because this is us telling the model what should it care about, right? So first of all, for the deterministic version of the AIFS, as I said, we use a mean squared error, so it's robust and easy to implement. It penalizes large error strongly, and this actually produces smooth fields, which is unwanted. In the probabilistic version of the AIFS, we're using a CRPS loss, so a continuous rank probabilistic score. It's actually harder to implement because we need an ensemble, but this type of loss actually evaluates the full predictive distribution. So in one case, we're actually in the mean squared error. In the regression loss case, we're actually asking the model to minimize the forecast error, while in the CRPS version, we're actually asking the model that the cumulative distribution function should match the observation step CDF function. So the result of the forecast can actually be quite different. Large errors might not be penalized in the CRPS version that much. What will be penalized is forecast distributions that do not that are very different from the observation step. So the results are actually quite different. So if we have a look here at the comparison between the AIFS CRPS and the AIFS Single, what is quite striking at first sight is that the AIFS Single tends to smooth the forecast fields quite intensively. So here we have a total precipitation forecast field, whereas if we compare the AIFS and the AIFS CRPS, so this is a single member that I'm showing here, we see that the structure is much more granular. We have higher high resolution features that appear here, and also we have more extreme or higher intensity events because we tend to smooth less the actual output. Now, this is also the case, for example, for other fields such as winds. So here I'm showing 150 hectopascal winds for day 1 and day 10. This is just a forecast, and we see here the difference in smoothing when we compare a single member from the AIFS ensemble forecast and the AIFS deterministic. The smoothing is quite intense in the deterministic version, whereas the AIFS ensemble manages to keep the scales more accurately. Now, in terms of the forecast configuration, Becky has already given a very nice overview of this, but as I said before, in the AIFS ensemble forecast configuration, we're using the same perturbed members as the one used in the AIFS ensemble. We have a control member that is started with the unperturbed initial conditions of the AIFS ensemble, but this one control member still has uncertainty because we are actually inserting noise in the processor. And in the case of the AIFS single forecast, the only forecast actually started from the unperturbed initial conditions in the AIFS ensemble control. And as Becky also mentioned before, it's a 15-day forecast on an NV20 resolution. I won't spend a lot of time on the scorecards, but the whole idea here that I would like you to take for the next week, where this will be treated more in detail with Thomas and also with Linus in 2 weeks, is that the AIFS models can be quite competitive and even beat the conventional models in headline scores. Here we have the scores for the AIFS ensemble version against the AIFS ensemble. So we can see that there's quite a lot of blue. When there's blue, it means that the AIFS ensemble model actually beats the conventional one. There is some variables where the AIFS ensemble struggles, such as winds, but overall the performance is quite remarkable. And the same for the AIFS deterministic. We have a very skilled model here, and that actually beats the AIFS control for most of the headline scores. We have some issues in the stratosphere. As you can see here, there are some red scores. But overall, the model is extremely skilled. But as I said before, in the deterministic version of the AIFS, we have smoothing issues that are corrected in the ensemble version. So where are we right now? For headline scores, data-driven models seem to be the best, but this is of course not the whole story. The AIFS Single, so the AIFS deterministic version, does not represent spatial scales correctly, but this is fixed in the AIFS ensemble version due to the different training strategy that is used. In terms of events, this will be treated more in detail in the next sessions, but the AIFS Single actually underpredicts extreme events, but is still quite useful. And the AIFS CRPS and AIFS ensemble actually produce similar results in this in the prediction of extreme events. And now just some words on future improvements. So in AIFS V2 that is coming, or that will be released at the beginning of 2026 together with the AIFS 50R1 cycle, we'll have new wave variables, higher model tops, and more recent data that will be used for training for even better scores. Also in V2, the AIFS CRPS will have improved forecast artifacts, which are currently an issue. We'll also be developing in the future higher temporal resolution, because right now we are forecasting with a 6-hour time step. A lot of users want higher temporal frequency, so this is actually something we are exploring. We are also exploring higher resolution models, so 9 kilometers, and in the next versions we'll also include ocean variables. So thank you. I hope this was useful, and now I will let Milana take over. Thank you very much.
Thank you very much, Gabriel. I will try to share my screen. Do you see my screen correctly? But on the wrong slide. Second. And is it the correct slide? No, it's not.
Yes, it is.
Yes, it is. Okay.
One.
Thank you.
Next one.
Thank you very much. Yes. Okay. Hello, my name is Milana. I am a technical outreach and engagement specialist at ECMWF, and I will show you now a little bit of a demo through PowerPoint on how and where you can find the AIFS and other machine learning products. And also after that, I will show you where you can find more information, because I'm sure this is a lot of information for today, and you will want to explore things after this webinar. So AIFS single graphical products are available for everybody openly on our OpenCharts. And as if you ever went to our OpenCharts, you will know that there's hundreds and hundreds of products over there, and it's not easy right away to find something, but to find AIFS single products, you can go to our charts ecmwf.int webpage. You can also click this in this presentation as well. And when you go there, actually, you will have to select forecast, because here we have both forecast and verification for our models. You put forecast and select AIFS single, and then you will filter out only the AIFS single products. There is currently 13 products here available publicly for AIFS single, and these are most important variables, and those that are most of those that are available from AIFS single. From AIFS Ensemble, there is a bit more products, simply because more can be calculated when you have the ensemble. So we have 26 graphical products. This includes 2 point-based products, which is meteogram, the standard well-known ECMWF meteogram, and Plume's diagram for 3 variables. Also, we calculate mean and spread for 7 parameters, and then this is displayed as well, and also probabilities for precipitation and temperature for products. How to find these? Well, you also go to charts.ecmwf.int, and now instead of AIFS Single, you can select AIFS Ensemble forecast. When you select AIFS Ensemble, you will get both these probabilistic products and the products from full ensemble, the meteogram, and you will also get the 13 products from AIFS control. So how, if you want to look at only at AIFS ensemble control, you can also filter out that as well. You will now see only the 13 products from AIFS ensemble control. These 13 products are exactly the same 13 products as AIFS Single. So you can compare them. So if I go back and forth, you will see that these are exactly the same. And you will also notice, because these two are different models, but you will notice these images are exactly the same. It's because these thumbnails here are from the step 0. So they are expected to look exactly the same. So if we go from AIFS Single and go to this other filter that is experimental machine learning models, you will see that we actually, if we click that, we will see that we actually run 4 other machine learning models. These are not ours, these are other open source models that we run experimentally for to compare our models with them, to know what's going on. But since we already have the products, we are making them available for our for everybody to have a look. There is only a few parameters available in this way, but they are there if anybody wants to use them and compare. So this was OpenCharts that are available for everybody. You don't need account, you don't need to log in. It is just there for everybody to use. However, for the forecasters in National Meteorological Services of our member and cooperating states, as well as WMO's countries, as Becky explained, you have the access to our ecCharts. ecCharts is more it's more clickable, it's more adaptable, you can combine. So on OpenCharts, the products are all predefined for you, the areas are predefined here. You can combine everything, you can combine parameter with other parameters. So how you can find the AIFS and machine learning models here? Well, it's similar, well, exactly the same to AIFS products. So all our layers are here in the layer list. So you can show layer list what you have here. I don't have anything, so I can go to add layers, and then here when you select here without filtering, you will see more than 400 layers. It will depend on who you are. I, as ECMWF staff, I have access to everything, but probably not everybody do. So you will maybe see smaller number than this, but you will see all the fields that are available to you, and AIFS will be there as well. So you can filter out AIFS this is just typing, so it's not predefined as in OpenCharts. So you can also type AIFS precipitation and you will only get precipitation. But if you type AIFS, you will get everything, both control and full ensemble calculated fields. Also, you can put AIFS Single, and then you can find you can only have here 19 matching items. Why is it 19 here and only 13 in the OpenCharts? Well, in OpenCharts, it's combinations of these parameters, and here every parameter is individually, and they are a bit bit more parameters than on OpenCharts. For example, on OpenCharts, we have only precipitation that is 6 hourly, and here we have precipitation, but also accumulated precipitation. You can also search for all the machine learning models. So if you put machine learning or ML, it will filter out all the machine learning models, including AIFS and all the other machine learning models. You see here in this screenshot that machine learning models are here below, and they have this black square around them. This means that this is experimental. Every time you see a black square, it means it's not operational, fully operational product. This can also happen when we have a model that is in test phase, both IFS and AIFS. You can in that time you will see the same product with the black square or without black square. Black square means that this is the test version or experimental version. So here all the models that we don't run are with the black square as test models. So let's here search for AIFS model, and here I want to show you how precipitation, for example, looks like. I would here click on the precipitation, and it will load total precipitation from AIFS Single for me. In ecCharts, you can put together AIFS and IFS product together, so you can see the difference between them. You can see the main difference here is the difference in resolution between these two. So and yeah, the difference in the forecast as well. You can also in ecCharts look for the point data. When you click on point and then visualize the probe, it will show you both of these values in this point that you chose. This is total precipitation from IFS and from AIFS. You have to note, and you always remember, that they are on different resolution. So this means that the nearest grid point that is shown here to the point that you chose might be different. So what is nearest for the IFS might not be the same point that is nearest to AIFS, which is the case in this situation. So we see that AIFS point is a little bit further, and it's different point. So this can also lead to different values. It can be different values in the same point, but even when it is a different point, it might be a different value. So this is something to consider. So here you can like this, you can look at the values at this point in this time step. However, you can also compare the meteograms for the one parameter, both from IFS and from AIFS for one single point. You will notice, although the numbers are tiny, that the axis on these two, even though it's the same start, they are different. So top one has, I don't know, 12, and lower one has 10. So these maximums, and for temperature it can be maximum and minimum, depend on the data. So if the data is different, the scales, the axis will be different. So it is making it hard to compare. And we are working on something to help with this. I will show you this in a few slides. You can also look at the meteogram for all the parameters that have available meteogram. It is the same parameters as in OpenCharts, and it's the same parameters for IFS and AIFS. So temperature, 2-meter temperature, total clouds, total precipitation, sea level pressure. So what we are working on is, because now we have two models, well, three, we can combine the products. We can create products that are combination maybe of these models. So first one that we are working on, so this is not available yet, it will be available in a couple of weeks. We want to plot both IFS and AIFS meteogram on one same plot. So then it is on, they have the same axis, and then you can, as forecasters, see much easier how they compare actually for one point. So this is coming, but it's not available yet. Because this might have been a lot of information today, we are also working on updating our documentation. So you can find the information about both AIFS and AIFS in our forecast user guide. So forecast user guide has a new section. It's section 2.2. About AI models at ECMWF, and I encourage you to read there, because there we will find information about differences between physical and AI models and what you should pay attention to when you want to use. So this is where to find the documentation and more about our and all of other products as well. Also, we have AIFS blog, where whenever we have something new, we publish a blog about that. So I encourage you to have a look as well. And because we are always trying to create new products, we want to we have ideas, but maybe you as a forecaster have idea what would you like the product to contain? If you have any ideas of a product that could have both IFS and AIFS, or from AIFS, share with us if you want. So if you have any idea, you can put it in the chat. Becky has shared a poll with you. I think it should pop up. It should be there for all of you. So if you have any idea, please put it in the pop-up. If nothing popped up for you, we are happy to have your feedback in the chat as well, because we will go through the chat afterwards as well and have a look. Yeah, my next slide is the final one. I want to thank everybody for joining us. We know that when you are off shift, you are most likely on your day off, or you are following this from a shift. So thanks a lot. I hope you learned something new, and I hope you will go to and explore the AIFS products. And also, we hope that you join our next two webinars, next Tuesday and the Tuesday the following week, that will tell you more about. So now you have a week to explore what is there, and then you can come and see what you need to be aware of when using ECMWF machine learning models, and also then in 2 weeks' time, some case studies that we've done on AIFS. You can still, if you didn't register for those two, you can still click on the link in my slide and go and register.
Brilliant. Thank you very much, Milana, and thank you so much to everyone today, and for loads of questions in the chat. So I'm just going to pull out a few of the questions which I hope will be helpful to you. The first one was just a clarification that all the models that ECMWF produce, so the IFS and the AIFS models, are all global models. They're not regional, they are fully global for all of them. There was a question about clarifying the criteria for selecting the 13 vertical levels in the AIFS. And the response there from ECMWF staff where we found these were most relevant levels for forecasting. However, future versions of AIFS will likely include more levels. So look out for that. The next one was more on, could you advise if there is a methodology available to generate forecast products between the 6 hourly AIFS outputs? So basically more forecasts, more shorter time steps. And I believe it was Mariana who replied to this, saying we are currently researching building a time interpolator model to interpolate AIFS outputs and outputs from other data-driven models with our member states. So this is an area of research that we're looking into of how to do this. Then we go on to resolution. So someone asks, is the model resolution determined by the ERA 5 resolution, which is what we learnt about from Gabriel? So the answer to that is yes. The current horizontal resolution of AIFS is the same as ERA 5, but we are exploring going to higher resolutions by fine-tuning on operational analysis. So again, another development area. Does the AIFS ensemble look physically realistic? was another question. Fields in the AIFS ensemble look more active than the AIFS single, which is one of the criteria for physical realism, but not the only one. So again, another thing that we're looking at. And please come to the next two webinars, which will go through this topic. They'll touch on this topic in a bit more detail, and you will see from the case studies how realistic these forecasts are compared to not only the IFS, but also observations. So that's what Linus will be presenting. And then there's various other questions going on in the chat. So requests for new products. I saw one about aviation. So we don't currently have those, but as Milana has said, please fill in the poll and we'll pass all your comments on. I think what you can hopefully see is that it's a very fast moving area. There's lots of things going on, lots of research, lots of new things happening. So in this area, it's so fast moving. I'm pretty sure the things we've said today may not be relevant in a few months' time as everything shifts and changes. Hopefully some of it will be, but we look forward to those updates. And please keep up to date on our web pages. So Milana's shown you where to find relevant information. The implementation pages for the model cycles are really important, and they'll show you what new fields, what products, what outputs. And also please test them, have a look, have a play, and provide us your feedback. The best way to do the feedback is via the support portal. So ECMWF support portal in Google, it comes straight up and you can provide us with feedback there, and we very much welcome it. So again, I say thank you so much for attending today. We hope you find it helpful. Thank you very much to Milana and Gabriel as well as many ECMWF staff who've been answering your questions in the chat. Yeah, hopefully see you at the next one. Thank you all very much.
Thank you all.